Hey everyone, how are you? In this video, we are going to solve the Leetcode problem of the day, and the problem is find the maximum length of valid subsequence part 2. Now the problem category is of medium level, and we have already solved the part 1 of this particular problem yesterday. It was the problem of the day yesterday, and it was marked as hard, but I would say it was a mistake. I would say it was easy. Today the question is of medium level. Now the problem is very much same as it was yesterday, as it was in the part 1. Now let me explain what's the given input in the problem and what's the output we need. It's very much similar to what we had to do yesterday, but the approach is going to be a little bit different. In this particular problem, the given input is integer array, let us call it as nums, and there is another integer and let us call it as k. The output we need to give is the length of the longest valid subsequence of nums. So we basically need to find a subsequence from our given input nums, and we need to find the longest subsequence possible which is valid. Now for this particular problem, what is a subsequence which you can call as valid? I will be explaining that now. So let us say we have a subsequence sub whose length is n. Okay, if the length is n, then the indexes in this subsequence is going to be from 0 to n minus 1, right? This is what happens in an array. So basically a subsequence is also an array, right? Now for every index I in this subsequence up to n minus 2, this particular condition has to be true. The condition is for every index I in the subsequence at the ith index plus in the subsequence at the I plus 1th index, when these two elements are added and taken the mod with the value k. So basically yesterday the question was very much same, but this k was fixed, it was 2. Now this k is a variable, and that is why I am saying that yesterday's question was easy, today it is of medium level. So the condition is for every index I in the given subsequence at index I plus in the given subsequence at index I plus 1, when you add these two elements and take a mod with k, for all these indexes I, this value will be same. So let me explain that with some examples. So let us say you create a subsequence of length 5, then the indexes are going to be 0, 1, 2, 3, 4. So I am saying that for every index I up to n minus 2, n is the length of my subsequence. So length of subsequence is 5, 5 minus 2, that is 3. That is for every index I from 0 to 3, 0, 1, 2, 3, this condition is going to be true, that when you find this particular value for any index I plus any index I plus 1, when you add these two elements, take the mod with k, for all the values this should be same. That is in my subsequence, when you add the 0th index plus 1th index element and take the mod with k, or when you take the I as 1 and 1 plus 2 index element and take the mod with k, when you take the I as 2, then in my subsequence the second index and third index element when added and taken the mod with k, and for index number 3, when the index number 3 element in my subsequence plus index number 4 element in my subsequence when added and taken a mod with k, all these values which are coming as an output, I would say, should be equal. They all are equal. That is whatever is my subsequence, right? Let us say my subsequence is of 5 elements a, b, c, d, e. So for every two elements a, b, b, c, c, d, d, e, this formula will be true, that when you say a plus b mod k, this will be equal to b plus c mod k, this will be equal to c plus d mod k, this will be equal to d plus e mod k, right? So basically this formula will be true for every two consecutive element in my subsequence. So now coming back to the input again, that you have given an array of numbers, nums, an integer k. Try to find the longest subsequence from this particular nums such that this formula is valid. Now let us see one example. In the example, let us say the given array nums is 1, 5, 2, 3, 4, 8, and the given value of k is 3, right? In this case, the output is going to be 4. That is, we are going to have a subsequence of maximum length 4 which is valid. That subsequence is 1, 5, 4, 8. And just to give you a short intro on what is a subsequence, you can select any element from your array from left to right in the same order what it is given in the array. You can select any element and call it as a subsequence. Like I am selecting 1, 5, 4, 8, 1, 5, 4, 8. This is a valid subsequence. If I say 1, 2, 4, 5, 1, 2, 4, 5, this is not valid, because although the elements are from my array, the order of the elements are not same. 1, 2 and 4 is fine, but this 5 is before this 2 and before the 4. So it cannot come after 2 and 4, right? So this is what a subsequence is. So for this given array nums, the valid subsequence is 1, 5, 4, 8. Its length is 4, right? It has 4 elements. And that is why the output is 4. Now let me explain you how this particular array or this particular subsequence is valid. So for every two consecutive elements, 1, 5, 5, 4, 4, 8, the condition has to be true, and the condition is 1 mod 3 plus 5 mod 3. This will be equal to 3, because this is 1 and this is 2. So 1 plus 2 is 3. Now for every two consecutive element, when you apply the formula, it is going to be equal to 3. You will see that for 5 and 4, 5 mod 3 and 4 mod 3, this will be equal to 2, this will be equal to 1, 2 plus 1 is 3. then 4 comma 8, 4 mod 3 plus 8 mod 3, this is 1, this is 2. So 1 plus 2 is 3. So that is what you need to do. You need to find a longest subsequence out of this. Now there is another subsequence which is valid. For example, the subsequence can be 2, 4, 8, and that is because 2 mod 3 is 2, 4 mod 3 is 1, 8 mod 3 is 2, 2 plus 1 is 3, and 1 plus 2 is 3. So this is also a valid subsequence 2, 4, 8, but its length is 3. We already have a subsequence whose length is 4. We need to find the longest subsequence, and that is why we are considering 1, 5, 4, 8. This is valid, and this is the correct answer. We need to return the length, that is 4. To solve the particular problem, you have to have some observations in the input as well as in the output. Focus more on the output, and that is because the output has a certain pattern which you need to understand. Let me first try to make you understand what can be the pattern. So you can see this particular calculations, right? For 1, 5, 5, 4 and 4, 8. 1, 5, 5, 4, 4, 8. What I will be writing now, you will have to notice something. 1 mod 3 is equal to 1, right? Then 5 mod 3 is equal to 2. In the second equation, we have 5 mod 3 equal to 2, 4 mod 3 equal to 1. Then in the third equation, we have 4 mod 3 equal to 1 and 8 mod 3 equal to 2, right? Here, if you will try to notice, you will notice a pattern that the pattern is the mod values are 1, 2, 2, 1, 1, 2, right? 1, 2, 2, 1, 1, 2. The next pattern, if we have more numbers, the pattern will be 2, 1. So basically the pattern is 1, 2, then 2, 1, then 1, 2, then 2, 1, then 1, 2, then 2, 1. That is, let us say the first mod value is A, then the second mod value will be B. Then in the next equation, the first mod value is going to be B, and the next mod value is going to be equal to A, right? From here, what I observe is, my first observation is, if my output has this particular subsequence, 1, 5, 4, 8. So we are not adding the elements, right? We are not adding 1 plus 5 or 5 plus 4 or 4 plus 8. We are adding the mod of our elements with the value k, right? If I take the mod of my elements with the value k, it will be 1 mod 3, 5 mod 3, 4 mod 3, and 8 mod 3. The values are 1, 2, 1, 2. And if the pattern is going to continue, this will be 1, 2, 1, 2, 1, 2. That will be the pattern. And I am going to prove that pattern to you, but that's my observation. And that is why when you add the first two elements mod, it is 1, 2. Then you add the next two elements mod, it is 2, 1. Then you add the next two elements mod, it is 1, 2. And if the pattern is going to continue, then you add the next two elements mod, it will be 2 and 1. Now let me try to prove that to you. The thing is, guys, let us say our subsequence is A, B, C, D, E, F, G. It has total 7 elements. I don't know the values of all these elements, but let us say these are my values, okay? All the elements can be different, can be same, I don't care. But let us say this is my pattern, this is my subsequence. Now, if I start taking the mod of A mod K, B mod K, C mod K, D mod K, and for all the values, if I start taking the mod, I will have some values, right? What I am trying to claim is, my pattern is something like this. The first element will be 1, then the second will be 2, then the next will be 1, then the next will be 2. That is, whatever is my first value, that will be my third value, that will be my fifth value, that is going to be my seventh value, and whatever is my second, fourth, sixth, eighth value, all are going to be same. That is, the mod values at odd positions, position number 1, position number 3 is going to be same, and the mod values at even positions, position number 2, position number 4, position number 6 is going to be same. That is because what we are trying to claim here is, if this is my subsequence, right, then we are saying that A mod K plus B mod K, basically the calculation with the formula for the first two values we are doing here, right? And if I try to find out the next two values calculation, it will be B mod K plus C mod K, right? What we are claiming, what we are saying that if this is a valid subsequence, then this particular value A mod K plus B mod K will be equal to B mod K plus C mod K, right? In both these values, this particular value is common, right? So I can get rid of this. I can say if they are common, let me neutralize these values, right? So what I am claiming right now is A mod K and C mod K is equal. Then only my subsequence can be valid, right? Alright, so from here I can say A mod K will be equal to C mod K, will be equal to E mod K, will be equal to G mod K, right? And similarly, B mod K, D mod K, F mod K will be equal. So that's the first observation we have. So let us say this is our subsequence, right? If this is my subsequence and for any given value of K in my input, for any given value of K, the possible remainder or the mod values, when I say remainder or mod values, what I am saying is A mod K, B mod K, C mod K, D mod K, E mod K, F mod K, G mod K. So whatever are the values which are possible for a given value of K, those values are going to be 0, 1, 2 up to K minus 1, right? The mod values cannot be equal to or cannot be more than K, right? For example, if the value of K is 3, right? And if my number is 10, 10 mod 3 will be equal to 1, right? You cannot find any number with which you take a mod with 3 and the value will be more than 3, right? It cannot be more than 3. When you take the mod, it will always be less than 3 starting from 0. So for a given value of K, the possible remainder or the mod values are 0, 1, 2 up to K minus 1, right? Dot, dot, dot up to K minus 1. So for K equal to 3, the possible mod values are 0, 1 and 2, right? Now based on these mod values, what we can think right now is See, the thing is, my pattern, my subsequence will have mod values, right? If my subsequence is A, B, C, D, E, F, G, H, if we are putting them in the formula is A mod K plus B mod K, right? These are the formula we need to put. We are not required to add A and B. We need to add A mod K and B mod K. And we know that the mod values will be equal for A, C, E, G and will be equal for B, D, F. So the alternate mod values are going to be equal, right? So from here, I am finding some possible patterns for any given value of K. Let us say the given value of K is 3. Then the pattern is going to be my last element will have a mod value, right? Let us say the mod value is 0. Now this F will have a mod value either 0 or 1 or 2, right? Now this E will have a mod value of 0, right? Because they both will have the same mod values. This will have the same mod value. This will have the same mod value. So there is a certain pattern here. The pattern is my last element can have the mod value of 0. My second last element can have a mod value of 0. Or my last element can have a mod value of 1. My second last element can have a mod value of 0. So there are patterns 0, 0, 0, 1, 0, 2 or 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Basically what I'm saying in this pattern is my last element is going to have this particular mod value. That is whatever is my last element. If I take the mod with K, I'm saying that the second value, this particular value in my pattern, in my all possible patterns, the second value is representing the last element mod value and the first value in this pattern is representing the second last element's mod value. For example, if this pattern is there 2 and 0, so what I'm saying is this will have a mod value of 2, this will have a mod value of 0, 2, 0, 2, 0, 2, right? And using this pattern, we can solve the particular problem. What we are trying to say is these are all the possible patterns we have in my number. Whatever is my subsequence, for example, my subsequence in this particular input is 1, 5, 4, 8. What are the mod values for this subsequence? 8 mod 3 will be 2, 4 mod 3 will be 1, 5 mod 3 will be 2, 1 mod 3 will be 1. 2, 1, 2, 1, second value is 2, first value is 1. So this is basically representing this particular pattern. So we are saying that if we are trying to find out a subsequence in which my last value is having a mod of 2, my second last value will have a mod of 1, then this will create the best possible pattern or the best possible subsequence. For example, if I know that this is my answer, then in this case, if I try to find out using my code or using some logic, then what I will try to do is I will try to say, okay, just run a loop in the reverse order. And firstly, since we are running the loop in the reverse order and we are trying to work for this particular pattern in which the last value will have a mod of 2, before the last value the mod will be 1. So I will first try to find out a value in this pattern which has a mod value of 2, right? Okay, so the last element is 8, 8 mod 3 is equal to 2. So yes, we found out our first element. The first element is 8, right? Starting from the back. Now since we found out a value which has a mod value of 2, now we will search for 1 because the elements are going to be alternate, right? So now I will move forward and try to find out a value which has a mod value of 1. The next element is 4. 4 mod 3 is equal to 1. So yes, we found out one more element of this particular pattern. That element is nothing but 4, right? Now you can see we are building this pattern 8, 4. We got our 8, 4, right? Now we are again searching for 2, right? We are again searching for an element which has a mod value of 2. Now we will move forward. 3 mod 3 is equal to 0. So we have not got our value. Let's move ahead. 2 mod 3 is equal to 2. We were searching for a value which has a mod value of 2. It is fine. We got it, right? So now our next element is going to be 2, right? Now we are going to search for an element which has a mod value of 1. 5 is my next element. 5 mod 3 is equal to 2. We have not got our pattern, right? We have not got our value. Let's move ahead. 1 mod 3 is equal to 1. We got our value, right? We got another value for which the mod value is 1, right? So now this will be 1. Now we are again going to move ahead and try to find out a value which has a mod of 2. But since we don't have any more elements, we are done, right? Now what you will notice here is this answer and this answer is different. But ultimately the length which we need to return, the length is 4, right? For this particular pattern as well as for this particular pattern, the length is 4. We wanted the length of the longest subsequence. Well, this was one possible subsequence. This is also a possible subsequence, right? 1 mod 3 is 1, 2 mod 3 is 2, 4 mod 3 is 1, 8 mod 3 is 2, 2 plus 1 is 3, 2 plus 1 is 3, and 1 plus 2 is 3. So even this is a valid pattern. I didn't know this pattern earlier, but while solving it right now, I got this pattern just from all the observations which we had. So this is also a valid answer. So from here we can say that if we have the value as 3, if the value of k is 3, there are total 3 number of possible mod values 0, 1, 2, right? And the possible number of patterns are going to be 3 multiplied by 3, which is 9. That is 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So what we have as of now is as an algorithm is k square because we need to work for each of the pattern, right? K square multiplied by n. N is the number of element in my array. So my algorithm as of now is n multiplied by k square. And I try to implement this algorithm and this algorithm was fine. This particular approach was fine that just run a loop and try to find out for each pattern in my given numbers that which pattern has the highest length. But the problem was this particular time complexity n multiplied by k square was giving time limit exceeded error. So we have to optimize this approach. So can you think of something which can optimize this current approach? Because the approach is fine. The test cases were passing, but I think I was able to pass around 690 test cases out of around 750 test cases. So this particular approach is fine, but the time limit is exceeding. We have to think of something better, right? So as of now, if I try to think about it, I am not using any extra space. I am just using a time complexity of n k square. Now, generally, if we want to improve our time complexity, we have to use some kind of space complexity. From here, I had a thought process that can I use some memory to store some result so that I can do my operations, I can do my processing in a little bit better optimized way. From here, my mind was, can I use a greedy approach or can I use the DP approach, dynamic programming or greedy? As of now, I am using greedy. It's not working. Maybe we can try for dynamic programming. Maybe we can think of some smaller sub problem which we are solving, but can we store that in some kind of space so that we can utilize that value later? So from here, my thought process was, let's focus on dynamic programming. Let's focus on this DP approach. And also what I observed is this particular pattern is also telling me one more thing. Let me tell you what. If this is my subsequence, then my mod values are 1, 2, 1, 2, right? If I start from the beginning, right? 1, 5, 2, 3, 4, 8. From here I can say that maybe 1 is going to satisfy this particular mod value, 5 is going to be satisfying this particular mod value, then 4 is going to satisfy this particular mod value, and 8 is going to satisfy this particular mod value. So my pattern is 1, 5, 4, 8, which is fine. But if you will notice here, if I'm trying to build this pattern, how will I try to build this pattern from the start? Not from the reverse, but from the start. So the thing is, let's try to find out my first value. This particular subsequence is representing 1, 2 pattern. That is, my subsequence will have the last element mod as 2, then 1, then 2, then 1, right? 2, 1, 2, 1. What if I don't have the knowledge of one of the element? I don't have the knowledge of 8. What if I have the knowledge of 1, 5, 4? I have a subsequence 1, 5, 4. I don't know that should we include 8 or not. Can we include 8 or not? Later on we will think about it. Let us say we have scanned these values and we found a pattern 1, 5, 4, right? 1 will have a mod value of 1, 5 will have a mod value of 2, 4 will have a mod value of 1. 1, 5, 4 is a valid subsequence of length 3. I have not seen 8 as of now. Let us think about this. This particular subsequence is representing the pattern 2, 1. That's because my last element has a mod value of 1, then it has 2, then it has 1, then maybe the pattern would have been more. This would have a mod value of 2, then 1, then 2. Last element is 1, second last is 2. So this particular subsequence is representing the pattern 2, 1, right? If I have a knowledge of the pattern for 2, 1, that is the last element will have the mod value of 1, second last will have the mod value of 2, can I use this value to find the pattern for 1, 2? Can I use this particular pattern to find the value for 1, 2 pattern? Yes, we can do it. And that's because the patterns are alternating, right? 1, 2, 1, 2. If we have a pattern in which the last element has the mod of 1, then 2, then 1, then 2, then 1, then 2. If you add one more element into this particular value such that the pattern is ending, the subsequence is ending with a mod value of 2, right? If you add one more element which has a mod value of 2, then this particular subsequence is now representing the pattern for 1, 2, not 2, 1. That's because the last element has 2, then 1, then 2, then 1, then 2, then 1, then 2, then 1 if we could have more elements than 1. So basically you will have to understand that this pattern is representing a subsequence in which the last element is having a mod value of 2, the second last will have the mod value of 1, and this pattern is going to continue from last to the first. So basically what I want to say is, if you want to find out the value for 1, 2 pattern in which the last element has the mod of 2, the second last will have the mod of 1. For 1, 2 pattern, you will have to say whatever is the length of 2, 1 pattern. If we found an element for which the element is having a mod value of 2, so I can say whatever length pattern I have for 2, 1, I will just say plus 1. And that's because, let us say we have scanned these values, if we know about these values, and now the next value is 8, right? If the next value is 8, 8 mod 3 is equal to 2, we got an element which is ending with a pattern of 2, right? So with a pattern of 2, which it is ending, and let us say we are trying to find out for a second last value of 1, that is, the last value will have a pattern of 2. We are saying that 8 is my last element in my upcoming subsequence, and before 8, whatever is my element that will have a mod value of 1, then this will be equal to whatever subsequence we have for 2, 1, because if you don't have this 2, I will add this 1. This 1 is for the new element, right? So I have to find the length of the pattern for 2, 1 and just add 1 into it. That's because, let me try to explain again. If I have a pattern 1, 5, 4, this is representing 1, 2, 1, basically the 2, 1 pattern. If I add one more value 8, now this will represent 1, 2 pattern, right? So whatever the length we had previously plus the new element. So whatever the length we have for 2, 1 plus 1. And that is the same formula we have to apply for each of my value. Initially, for all my pattern, the value can be equal to 0. That is, I don't have any value for which this pattern is having any kind of subsequence, right? Initially. Then we are just going to scan each of the value one by one, and we are going to update our DP table, dynamic programming table, which is actually storing some result. And this is going to help us solve this particular problem, because now we are not trying to solve this particular problem in n multiplied by k square algorithm. What we are going to do is, we are going to say, we are going to scan each element, and for each element, we are going to find out the mod value, right? And whatever mod value we get, for example, if the first element is 1, then 1 mod 3 is equal to 1. So I would say I got an element for which the mod value is 1. This is my second element. This is my last element actually. So before this, I will have different set of values which has the mod values of 0, 1 and 2, all the different k values, right? So what we are going to do is we are going to solve this particular problem in a time complexity of n multiplied by k, and that is because n will be for each of the element and k will be for each of my mod values which are possible with my current mod value, right? So using this pattern, if I try to solve this particular problem, so what will happen? My current value is 1, right? My current number is equal to 1. 1 has a mod value, 1 mod 3 is equal to 1, right? This is my mod value. So what I'm going to say is, okay, let me put this 1 as the last value I have. If 1 is my last value and the mod is 1, so the second last value, I don't know the second last value, so I'm going to put all possible mod values here in the second last. So the last mod is 1, the second last can be 0, can be 1, can be 2, right? So the possible patterns are 0, 1, 1, 1, 2, 1, right? To find the value for 0, 1, this will be equal to 1, 0 pattern plus 1. This will be equal to 1, 1 pattern plus 1. This will be equal to 1, 2 pattern plus 1. This is what we are going to do. And based on this, we are going to update our values for each of these patterns, and whatever is the highest value, whatever is the maximum, that's what we are going to return, right? Because that will be the highest length, that will be the maximum length, right? So this is the complete thought process of how we solve this particular problem. And now let me take you back to the code editor and let me try to show you the solution of this particular problem. And the solution is very clean and very easy to understand. First of all, we are trying to create the data, the DP table data, in which all values are 0. And this is a two-dimensional array for all the possible patterns of k. Basically 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2, right? All those patterns will be covered in this particular data. So basically we are just running a loop in the range of k, and for every value of k, we have another array of size k in which all elements are as of now 0. Then the result is equal to 0, which is saying that as of now we have the maximum possible result, maximum possible subsequence length as 0. Now we run a loop in our array, in our given input array, and for each element of n, we are going to say my current mod value is n mod k. Now for all the possible remainder or the mod values in the range of k, I am going to say in my data table, in my DP table, data of rem, comma, current. Current is my current value in my array. I am going to say this is my last value, and the second last value will have all possible mod values. This will be equal to data of rem, comma, current will be equal to data of current, comma, rem plus 1. This plus 1 is for my current value. I am saying that this value will be my last element in the sequence. Just add 1 into it, and whatever is the value, whatever is the updated value we have, I would say result will be equal to the maximum of the current result value I have, comma, the new updated value, whatever is my new updated value, right? At the end of this loop, I will have the maximum value present in my result variable. I can just submit this code, and this is going to pass all the test cases in a very efficient manner. So yes, you can see that the runtime is pretty good. The memory used is pretty good as well. So we have solved this particular problem in a very efficient manner, right? And the approach we have used is the dynamic programming approach. So guys, that's it for this video. I hope this video explains you the problem, the solution approach, the intuition behind this solution. And if it did, then make sure that you hit that like button. And if you have not subscribed to my channel as of now, then make sure that you subscribe to the channel as well. We are very close to 1000 subscribers. So I am hoping to achieve that milestone in this video. And I will see you guys in the next video. Thank you for watching this video, guys.